The topic is serverless revolution, right? So this is a very trending thing what's happening in industry today. We'll try to we'll try to understand today about the historical monolithic architecture. Then we'll talk about the legacy SOA based applications, and then we'll go for the current trending microservices architecture and the future serverless computing. Though it's, I say future, it is happening now. So in this we talk about AWS, Microsoft Azure and Google Cloud Platform, and finally we'll talk about the Gartner's hype cycle, right? This is one interesting point which I will be concluding my session with. So we'll try to understand this. I request all of you to understand what I am trying to say. I will start my session with a small example. If you understand the example very well, it's a very simple and similar example. If you understand this better, the full concept what I am going to talk today is done, right? So I will talk about one simple business, about pizza delivery business. Okay, so this is just to understand the concept. Earlier you assume scenario 1, I am talking about a case 1 where a single pizza shop where everything happens under one roof. Maybe a pizza shop or maybe a hotel. You take a single, we see some small hotels in our hometown, right? So there is a hotel, right? It's a single place. There is a, maybe in this this back of that hotel there is a kitchen here where the food is prepared, and there are people working inside the kitchen, and we come here and dine. We have our food here, right? A single place. Okay, so there is a single kitchen here. Okay, so how it works generally? How does it works? One large kitchen makes the dough, prepares the toppings, bakes the pizza, and packs it for delivery. Everything happens here only. We have seen many times in restaurants that there is a kitchen place where they prepare everything there itself. The packing, or distributing in plates. Everything is done here only, right? And everything A to Z they do. Even the delivery is also done by the same team. They only come out and they serve you on table. Assume this is scenario 1 I am talking about. So there is a hotel or there is a restaurant or some pizza shop where in the kitchen everything is done by some set of people. Maybe some 10 people are working in the back end in this kitchen. They are preparing the food, whatever we are ordering, and it is being served us to the table, right? So my point here is a single unit managing everything. Okay, so taking the order, preparing the food, delivering it, and the payment. So this is all a single people, means a set of 10 people are doing this business. We see this kind of places very frequently in our hometowns or some small cities. We see such hotels where there is a single guy who is doing everything, or some set of people doing the whole business, right? This is one. Now what is the challenge in this? No, this style is very good. It is interesting. We see this frequently. There is, I told you, there is one kitchen here, right? So there is one cook, head cook, or only one cook is there in this hotel. Okay, suppose someday the cook is not feeling well. There is only one cook in this hotel, one person, and because it's a small hotel, there will be only obviously one cook, or a single person might be preparing the food and delivering it, right? So in such case, if this cook is not feeling well, or if a cook is unable to come to the hotel today, what will happen? Will the business run in that day? On that particular day, the hotel will not function. Okay, they cannot deliver the pizzas because the actual person who makes it is absent. So it is a problem here. That's why everything is tightly integrated. Only one person sits in the counter. Only one person knows how to make the pizza or maybe any food item what we order, right? And again, in this kitchen there is one oven. If the oven also breaks, because we make pizza in the oven or something, you can say as some gas is not there, right? If any one component is not functioning in the kitchen part, the whole restaurant will be closed, or not closed, but it will not function that day because they cannot provide the service, right? So scaling requires adding more staff. Now what is the alternate solution for this? Okay, scenario is there is a single kitchen, there is a small hotel, there is a single kitchen in that, there are some small set of people working on that, and only one cook is there or only one oven is there. If any one small thing breaks, if doesn't works, then the functioning will not happen. Okay, what alternative solution we have? You may say, yes, we can add more people. Why to have one cook? Why don't you bring second cook here, C2, when there is already C1? If anyone is available, business will work. But to include C2, I have to pay extra money. This is a very small hotel I am talking about, right? Why I need 2 people there when a very less number of customers come to my restaurant? So it is difficult to include C2 or C3 as backup. Sometimes there is no customers at all, sometimes there are high customers. But when there is no customer on some Sunday, maybe or maybe some Monday morning, nobody comes to hotel generally, if you assume, then this second cook, this first cook, everybody will be in ideal state. They will not have any work, right? This is scenario 1. Remember this, I summarize what is scenario 1. It's a small hotel, it's a single unit, everybody is working together from beginning till the end. The whole process is taken care by the same set of maybe some 10 people in the kitchen. What is the drawback here? If any one is absent, somebody does service, one fellow is meant for billing counter, other fellow is making for cooking, other fellow for washing the vessels. Like this we have some fixed people. If any one is absent, the process gets very delayed, or it may not function also. This is scenario number 1. Let me take you to the second scenario. Now let's have a second case. Again, I have the same pizza delivery business, right? What I am doing here, I have some specialized teams. Okay, so what I am doing, the alternate solution, the previous one, I in the kitchen part, I am having cooks. Okay, maybe there is one person, C1, C2, C3, C4. These people are specialized people, meaning he can even cook and he can even do the service. Okay, C3 can cook and C3 can do both the things. C3 can do cooking as well as cleaning vessels. C1 can also cook and also do the service. Like this, one person is not having one role here. They are doing multiple businesses. They can do 2-3 activities. So even this cook one, maybe in this 4 people, if you say C1 and C3 are 2 employees in that particular kitchen, where both of them know cooking. But this fellow is meant for cooking today, this fellow is for doing service. Even if C1 is absent, we have a backup C3 who can help us in running our business, because he can do the preparation of the pizza, or he can do the cooking part of that particular restaurant, right? So we have specialized teams. The focus is on specialized teams. So meaning a person can do multiple things, right? But they are still coordinated by a central manager. There is one person who is managing all that, right? He is taking care of all those processes in that, right? How does this works? Each team communicates through internal phone system, assuming they talk each other. No, this is the cooking part, this is the cleaning part, this is the service part, here there is a billing counter. So they talk over some landline phones if they require, and there is a central manager who coordinates. Okay, little bigger business compared to the previous one. The previous one was very small hotel. This I say a medium level hotel where people, we have some specialized teams, right? But what is the problem here? Are there any problems here, right? See, though these people are now, who has to, what is the common problem here? I said that C1 and C3, both of them know cooking, but there is a manager. Manager is telling C1, today your job is to do cooking. C3, you have to clean the vessels. Tomorrow, next day, he will only assign the work, because they will otherwise they will fight each other. No, who has to prepare the pizza? No, you know cooking, you make it. This is very common, we see. So these 2 people will fight. So there is a strong dependency on a central manager. A manager is required who will be assigning the work. Okay, these 3 days you work on this kitchen, these 3 days you work here. So that manager is required. Without him, this cannot function. Otherwise, people will not work, because both of them know cooking. I am talking about only very medium level kitchen or a restaurant, right? So they need one central manager here. If central manager is not functioning properly, there is a problem. This business cannot work, because they will fight among themselves. Why I should work? That the employee is not working, he is enjoying, he is using mobile phone, I am working so hard. So this is very common we see here, right? So the main problem here, in the previous case, if anyone, in this case, in the first scenario, if the cook was absent, whole business gone. If the oven is broken, the whole business gone. In the second case, there is a strong dependency on the central manager, a manager. He has to manage all those people in the kitchen. Without him, it is difficult. right? And again, scaling is also a problem, meaning if I want to have expand my business, if I want to expand my business, how will I do this? I cannot, because I have less space here. To expand my business, I cannot. Even if there is, you say Sunday morning, this is a special restaurant where some biryani is very good, then there is a huge line in front of the shop. But when the demand is increasing, this fellow does not have more scope to expand his restaurant. Okay, so even if he brings more people, there is less space for the people to sit. This is also one more challenge. Okay, scenario number 2. I am again repeating 1 and 2 because this will take just 5-10 minutes to understand 4 different scenarios. That's it for understanding today's concept. Okay, so scenario 1, a small business, there is a strong dependency on each employee. If any one is absent, if any one equipment is not working, the business cannot function. Second thing is very good. We have specialized teams. We have a backup cook. If one cook is not there, second cook can work for us. But there is a necessity for one central hub or a manager who can help in interacting between both the parties, right? So that is about the second scenario. When I go to the third one, here what we do, we divide, again the same pizza business in the same restaurant part. Here what we do, we have a different teams. Previously in this kitchen, in scenario 2, when I was talking about scenario 2, there is only one kitchen. Here there were people working, but they are just specialized. If he is cooking, he is doing other work. If he is not available, he can do the cooking for us. So that is okay here. But in this scenario 3, third scenario, what we are trying to do here, in the kitchen, you have separate teams. We have divided it like this, and there are some 3-4 employees in each. Okay, their job is to complete their task. Okay, so transforms into a network of independent small businesses. So this pizza has been transformed now. This team is separately looking after dough preparation. They are looking after some delivery service. They are looking after payment service. They are looking after some topping. Like this, we have 4 different independent small units in that restaurant. Each one's job is to only do that thing. There is no need of quarreling. No, if there are 4 employees in the cooking part, their job is only to cook. They will not do any other business. Now, what is the difference between scenario 2 and 3? In 2, I said they are all working in a single kitchen. C3, C1, C2, they are multi-skilled. They have multiple skills. So even C3 can cook, even C4 can cook. But since everybody knows cooking, who has to cook? That central manager is deciding. Here there is no need of central manager. In this, we are having 4 separate business units. Okay, these people's job is to only make the maybe they are preparing only the that pizza. So they will only bake and give. Somebody's job is only to prepare that dough, the batter kind of thing, what is required for preparing the pizza. Their job is to make only make that thing. So there is no difference. They are all independent. Their job is to complete it. That's it. They are not interacting. C1 from here, C3 from here. They need not change their roles. Their role is fixed. What he has to do is fixed, and we have multiple people in that, right? So they talk to each other independently. They will C1 first unit 1 completes their job and then sends that to unit 2. They will do their job and they will send it to unit 3. Then they will send it to unit 4. Like this, the business goes in scenario number 3, right? So independently scaled, meaning in C1 in the cooking part. If you talk about the cooking area only for making the pizza, there are people in that, multiple people in that. If somebody is not there, other fellow can work. Okay, so if there is a demand, they can increase it. 4 employees they can bring. If there is no demand, they can make it 2. That way they can adjust here, right? So that is about this scenario 3, where we have divided completely into separate independent units. Their job is to do only dough preparation. The other job is only to make bake the pizza. Another team job is only to do the delivery. So we have no problem at all here, right? This is also one of the successful ideas, scenario number 3. Again, before I go to scenario 4, let me summarize scenario 1, 2, 3. In 1, we have a small shop, a single unit, everybody working in that, and there is a strong dependency on single person. There is only one cook in that. There is only one person who can make the payment or collect the payment. There is only one person who is actually doing the service. or cleaning the vessels. So if any one is absent or if any one component is broken in that, business will not function. Scenario 1. Scenario 2, no, to avoid that problem, we have got some specialized team, meaning a single employee can do multiple things. There is a manager who will be assigning work. Today you do this job, today you do this job. A single fellow can do multiple things. That way they got it. But there is a strong need for a central controller. There is a single person is required who can manage all those people, right? Then in the third scenario, they completely divided. They have separate independent units. Each unit will do only one task. That's it. Okay. Then comes scenario number 4. This is a very clever way of doing business. What they do here, they have a restaurant here. Okay. They bring in the kitchen part, they don't have kitchen here. They have very, very less kitchen space. Very, very less. What they do here? Here in this case, they will outsource everything. Meaning they will get the there is some shop. This is somewhere near some center. Okay, at location X this hotel restaurant is there. At location Y there is one place who is selling only the dough or the pizza what we say dough, the batter which is required to make the pizza, the flour, all those things. They are selling only that, right? So you get it. Meaning, again, in simple terms, if you want to understand, I'll talk about a simple example of dosa. We know to make dosa, we need batter, right? So otherwise, in the previous 3 cases, they have to soak the grains before the night. They have to grind in the morning. Then they have to make dosa. This 4th case, what he is doing. He is not doing all that headache. He is getting that batter from outside shop. He is just having a small kitchen here, making dosa and just serving here. So he is not having the headache of getting that preparing that dosa batter. He is getting it from outside, right? So everything he is getting from outside. He is only having a place. He is doing business here. Whatever is required, he is outsourcing everything. He is not having anything in this. So what is the benefit here? You see, no permanent kitchen or infrastructure. Okay, contractor is on demand. Today for this business, today there was one supplier. There was one fellow who was supplying milk for us. If he is not supplying milk, I will get from somebody else. Or curd, you say. If this was the curd supplier, if he is not supplying, I will take from somebody else. If not he, I will take from somebody else. I will not make the curd. My business, I am not involved in that. I am taking all those things from outside, ready-made, I am bringing it and I am just doing the business with that. This is 4th category. Okay. So dynamically, if there is, okay, now this is a restaurant, 4th scenario. If there are 1,000 customers coming, generally they come 500, but today 1,000 people came. He will go to that shop, get more dosa batter and come here. That's it. He need not worry. There is a supplier who is supplying dosa batter ready-made. So I will not worry because I soak some grains, I make the dosa and 500 people, 1,000 people came. I had only for 500 people. Remaining 500 has to go back. No need to worry. He will not take that headache. This restaurant fellow 4, scenario 4, he will go and get the batter. There is full supply from this vendor. He is giving batter. Go get batter. More people are coming, go get the batter. There are batter suppliers. So that's why it can dynamically it can expand. Let 1,000 people come, let 10,000 people come. This fellow can serve. He has no problem of cook. He has no problem of the equipments or the ingredients required to prepare that food. He will get it from outside fully. He will not do anything he will not have the kitchen at all. He is just serving food from getting outside. But he is running his business. He has a good restaurant. He has a good name. It is running successfully. From where the food is coming, he is getting from outside. Okay. So this is the 4th scenario, right? All these 4 scenarios, we have seen different challenges. Okay. So what are the challenges in each of the scenarios? In scenario 1, if you see in the first scenario, if the cook is not there, business will not work, a small business. Or if the oven is not working, I cannot do the business. In the second, though I have specialized teams, this is a very good idea. You have specialized people. This is one of the successful way of running business. What is that? You have multiple people in that. Everybody, they are specialized. Each person can do multiple tasks. Some can prepare, some can do, a single person can do multiple things. But there is a need of a manager. Manager tells you, today you do this, he will do it. Tomorrow you do the other job, he will do it. That way we have this very good. This is one of the successful ways. Third one, more better. To avoid that What we are doing, we are dividing that into small business units. Each unit, let them do a single thing. Let them do a single thing only. Okay, so you need not worry about cross team working. The C3, C1, they need not talk to each other. C1 is in unit 1, C1 is in unit 1. His job is to just prepare the pizza, to bake the pizza. That's it, he will do nothing else. He will only cook the pizza, I mean to say, right? So all the people in unit 1 will only doing cooking. That is the third scenario. And the fourth scenario is outsourcing everything. You do business, you run a restaurant or a hotel, but you bring it everything from outside. You have a very little space just to heat the food and serve. You are getting everything from outside. You may have a kitchen, but a very small kitchen, right? So you don't do all those cutting of vegetables, everything. There is somebody who is selling cut vegetables, already chopped vegetables. So he will get those chopped vegetables from outside, and he will just cook it and heat it and give it to the customer. So he is not taking the headache of peeling all the vegetables, cleaning them, that and all somebody else is doing for him. So he is running his business this way. This is fourth scenario. If you understand these four, the differences, now we go and see, right? The scenario 1 which I was talking about, that single pizza shop, that is monolithic architecture. Okay, monolithic style. Mono means single. There is a single person who can only cook. There is a single oven, right? So everything is single in that business. Okay, so that style of doing business here in this context, it is called monolithic architecture. We will try to see this, we will try to understand. When I talked about specialized teams, meaning C1, C2, C3, C4, there are 4 employees. C1, C3 both can cook, C2, C3 both can clean vessels. So they can do, they are flexible enough to work in any of the teams, right? That is your SOA, service oriented architecture. Now when I talked about the third scenario, independent pizza services, we made unit 1, unit 2, unit 3, unit 4. Their job is only to bake, their job is only to do service, their job is only to clean the tables, they are only for billing. There are specialized teams, so that they need not always fight with others. They have their own job to do and they are doing it happily, right? That is your microservices. And when I talked about outsourcing, that is freelance pizza contractors, everything I am getting from outside. There is somebody who is delivering every day morning as soon as I open my restaurant. There is somebody who is bringing me dosha batter from outside. There is somebody who is giving me the curd. There is somebody who is giving me the some sweets. I am just running my business. Okay, so that part is your serverless computing, right? Now let's understand technically what are these aspects. What is monolithic? What is SOA? What is microservices? Where do they fall? We'll try to understand. I hope you got little idea about these 4 terms, on what are the challenges, why today these 2 things are very successful, other things are not in existence. We will try to understand why the serverless computing is the current trend or the future what we see, right? This is very, if you remember in this business example, it's very good, right? You have a place with you, you are running the business. Okay, in this you have, if you are having 50% kitchen, you can accommodate only some 500 people here. But if this is not there, you are having a small kitchen place, you can accommodate some 1050 people, more people can be accommodated, right? Double than what we have. Why? Why very less kitchen? I am getting everything from outside. I don't need space to clean vegetables, to prepare anything. I am just bringing, maybe slight cooking I am doing, or slight heating of the food I am doing, I am just supplying. I have a brand name, it is working fine. People are coming and eating. Food is coming from the kitchen. Where the food is coming to the kitchen, that is coming from outside, right? So that is this is very, very trending and interesting concept. So let's go and try to see each of these. What is monolithic, what is SOA, what is microservices and serverless. I will begin, before I go, I will talk little about this one concept, quality of service parameters, right? So when again all these are used for designing software applications. Okay, so you want to design any software application, any website you want to design, any app you want to design, or any banking software or passport software, a lot of softwares are there, or any apps like Instagram, Facebook, whatever you talk about, right? If you want to design any software application, these are actually the architectural styles, right, to design the applications. Okay, so when we design software applications, we have to talk little about these quality of service parameters. Okay, what is this? We'll understand through example, right? The first one is availability, right? Availability means you understand. When you access a website, it should be available. It should be up and working fine, right? So some applications you see, some software applications, some websites which you open, sometimes they don't work, sometimes they are working, right? So availability means the uptime percentage, how long the application is up, right? The degree to which a system is operational and accessible when required. What is availability? Some shops are open only from 6 to 10 or 11 p.m. They are available only with this time. That is their availability. But software applications, they should be available 24/7. Right? Anybody can access anytime. Today, you cannot say night, since in India everybody is sleeping. We cannot say you cannot use Snapchat in the night. That is wrong, because it needs to be available continuously. So availability is about the degree to which a system is operational. How long the system is operational. Is it on available 24/7? All our applications like WhatsApp, Twitter, whatever we use, they are 24/7 available. Their availability is 100%. I will not say 100, but it is almost 99.999 something, because sometimes there are some small outrages in that we see Twitter is not working, Instagram is not working, so we cannot say 100%. No application is 100% available. So availability is a property which talks about how long is the application working fine. Is it available 24/7 or not? Okay, that is about availability. Second, performance. How fast I get the response. I give a request, I open a website in the browser, and how quickly I am getting the response, right? So if you remember your SSC results, your 10th class results, right? You might open some website, government website or some other websites, you will give your hall ticket number, right? So generally that website, when you give hall ticket number, you might have experienced this. You take so much time. The result, for somebody it comes in 1 second. For somebody, even after 2 minutes, it is still loading. It is still loading. You will see it is not responding quickly, right? So performance is all about how fast a system can respond to the user request. Okay. To understand those 4 architectural styles, you need to understand these parameters. First one is availability, second is performance, right? Then scalability, right? Scalability means there is a website, okay, maybe I'll talk about Book My Show. You use it frequently. Generally, Book My Show is nicely available, right? People hit it, you can book the ticket, there is normal load in that. But when they are releasing IPL tickets, right? When they are releasing IPL tickets, you know the demand on this website or any other website where they are launching the IPL tickets, whatever it might be. There is an application which was normally working fine, but when they are launching the IPL tickets, what's happening there? The system is performing slow, right? So they are unable to scale up. Generally, this Book My Show website is designed to handle 1 lakh customer per second, 1 lakh hits per second. But when they are releasing IPL ticket at 10:30 a.m. or 10 a.m., we are getting almost 25 lakhs hits. So scalability is all about how can the system handle the load, right? So it should have some mechanism such that even it is 1 lakh, it should work. When it is 25 lakh, it should work. It will not work, right? So we have to scale the system. So this software application which you are designing should be scalable, meaning it should switch accordingly. When there is a low load, it should work fine. Even when there is high load, it also should work fine, right? It should give better responses even when there is high load. That's about scalability. Reliability. So ability of system to operate without failure, right? So strongly reliability comes. The same software application I will take again here in this application. 10 Tatkal train booking, right? 10 a.m. we do train booking at 10 a.m. No, sometimes you see how many times you try, your mobile app will not be functioning. There will be some failure coming in that. You fill the details, you go to the payment. After payment, it fails. Again it fails. Again it fails. N number of, maybe sometimes for everybody it is failing. It's not working, right? So the software is less reliable during that time. Reliability means it always gives failure. So system is reliable when it operates without failure. You give a request, it should become successful and get the response, right? So that is one case. We talk about reliability. Security, you understand about the attacks, the unauthorized access and the attacks to that software application. Interoperability, meaning the ability of system to work with other systems easily. Okay, so the best example is the fitness app that integrates with smartwatches, right? It is taking care of heart rate, you are pulling your step counts, right? Even in the watch you can see those, even in the mobile phone you can see that. Okay, so it is interoperable, it can work with external systems. Maintainability, okay, this is one interesting part we need to know to understand those four systems. What is maintainability? Somebody has designed a website, okay, he has written some 10,000 lines of code, 10,000 lines of code. After writing 10,000 lines of code, that developer left, that person, that employee who wrote this code has left the organization, he went, somebody else was appointed. Now this fellow is given this 10,000 lines of code, and the manager says you have to make a change, add one more new feature into this 10,000 lines. This is a software application, it contains 10,000 lines. This employee who wrote has left, you came and joined the company, the boss is telling no, you make the changes in this application. So this is for him that he has to make changes in this application. Okay, does he know what is this? First, the biggest challenge is he has to understand the whole 10,000 lines. Before making any new change, he should know, he should understand the whole application first. How is the code written? He has to read those 10,000 lines. After reading those 10,000 lines only, he can make a new change. Simply he cannot make that change anywhere in the program. You know, even if you make a small change in the program, one small single change, one character change, you make the whole program misbehaves. So when this new employee is appointed, he is spending so much of time to understand this code and make the change. Okay, so maintainability is all about the ease with which a system can be updated, fixed and modified. Okay, so maintainability doesn't mean that also. One scenario is this, one example where a new employee comes, he has to spend a lot of time. Maybe the same employee is there, the same employee who wrote this code is there. He should know where he has to make the change. So the application should be easily maintainable. I want to make a change in that, I should be able to make it very easily and within less time. Right? So that is about maintainability. Throughput, again, the number of requests satisfied per second. In a second, how many hits the application is taking, that's about throughput. Okay, so I will be talking about these parameters here and there when I am explaining about these four architectural styles. Okay, so let's see the first one, monolithic architecture. Right? So I said again, this is business scenario number 1, if you remember, where there is a kitchen. In that there is, in the kitchen part there is a cook, there is a person who can clean the vessels, right? There is some service boy, there is some billing person. Okay, a single, and there is only one oven in the restaurant. So monolithic architecture, what is this style? Earlier, maybe before 2000, when internet was growing, everybody used to build application only with this style of monolith or monolithic architectural style. Mono means single, means it's like you write programs in your laboratory. You have some programming subjects, you might be writing some programs. All those programs what you are writing are monolithic in nature. Why? Because for a given problem, you are writing only one solution. You are writing only one code, maybe some 100 or 200 lines of code you are writing, right? So what is this monolithic style? It says that when you are building application, you have to write a single program. It doesn't say you have to write. People used to follow this. Any application to build, they used to write a single very large program of 20,000 lines of code. Okay, so any application, they used to write a single program only. There were no, before 2000 I am talking about, there were no other styles of doing it. Somebody gives a problem, asks you to build this, you will write only a single problem, you execute the program, you get the output. That way they used to write. If you remember this client server architecture, client server model, you might have heard this. So there is one client, there is a server here, this is a single machine, This is a single desktop or a laptop machine. In this, I have installed the softwares. Okay, I write the code, I test the code, and I deploy the code here only. Okay, so there is a single server, the software is there only. This is a client, there can be multiple clients, C1, C2, C3. They will be sending a request to this server. Server will give the response. He will send a request, server will give the response. Likewise, they were interacting. So these are dummy machines, they are just very small machines, but the actual software, actual writing of the code, testing, everything happens in this. When do we call a server? What is the difference here? Server is nothing but a single system, a system which has high configuration. Client is something could be assumed as a system with low configuration. So obviously, we will be installing the software, we will be writing the code, everything in the server only, not in the client. So server is a single machine which has some better configuration compared to the client machines. Okay, maybe I'll talk about one banking example. A state bank or bank, right? In New Delhi, there was only one bank. Earlier, there was only one bank, right? In this bank, there is only one system where they made one software. Using small technologies, they wrote some programming, C++ or Unix programming, they wrote one software, right? So there was only one bank. So what happens here? This is a machine, this is one desktop machine. In this machine, they wrote the program. They have the software, they wrote the program. So there was one person working here, people used to stand in line, they will come, they will say my account number is this, he will be entering the details in this software, right? So there was only one queue line and only one laptop machine or desktop machine, right? People used to do their business here. Later when the crowd increased, what they did, instead of they made this machine as a server machine, they made some client machines, small systems they have organized here. So people who want to deposit can go here. People who want to withdraw money, they can stand in this line. People who want to do other transactions of check or DD related, they can stand here. What all these three people are doing? They are all hitting the same server, sending request from this machine to this machine used to give the response, right? So client and server architecture. Now when I say about server, if you see the server part, right, it's a single machine which has good configuration. So in that single machine, we used to write a single program. There is a single program which we are writing of 20,000 lines, 20k lines of program, right? So this is about monolithic architecture. Mono means single. Now what is the challenge in this monolithic architecture, right? What are the challenges here? Okay, see what is this monolithic architecture? It refers to a software design pattern where application is built as a single unified, right? It is built as a single unified unit. All the components like user interface, the business logic, the database, everything was in a single machine and they used to run as a single process. See, what is the drawback here in client server? When I said there is one central server and there are so many clients, right? There are so many clients. This machine, this computer has that software, it has that code, it is working fine. But if the server is down, the whole business stops. This system gets crashed, the whole system stops. If the power failure happened, some short circuit happened, this whole software is gone, you cannot do the business. That is the drawback with this, right? One drawback. If the same thing in the kitchen, I told you, if the only one cook is there, if that cook is not working, the whole business will stop. In the same way, if the single server, if you are writing a program, if you are building your application as a single entity, and if that single entity, if there is some error in that, okay, this is about hardware failure or some power problem, right? Server is here, if there is some power problem, if there is some system gets crashed, this software is down, then none of your clients can do the business, banking business. That is one drawback. Another drawback with monolithic, right, is that you have, I told you, you have 20,000 lines of code. You have 20,000 lines of code. In this, one person comes and develops the application, he leaves. Second fellow comes, how can he do that? Employee 1 wrote this code, maybe in 2024. Say this fellow left the company. Then that boss got another employee in 2025. He is given the task to make the changes. In this whole 20,000 lines, he has to make a change. Where will he make? He has to understand the whole thing. Even if you miss some part, one line, two line, the business will not work functionally. The application will not work properly. That's a drawback. So like this, there are so many drawbacks in this. Lack of flexibility. I cannot no. Even this 20,000 lines program is working fine. Assume, but I found one change, one bug, or government says no. Maybe this banking example, if you take, this is banking software. Okay, so there is about withdraw, there is about deposit, pin change, no, some check related, DD related. We have so many such different code functions in the single program. Tomorrow government says no, the interest rate from 5% we made it 6%. So somewhere in the deposit part, I have to change the number 5 to 6. To make this small change 5 to 6, the whole application I have to stop. Why I have to stop? Because it's in a single server, right? It's available in a single system server. There are clients who are connecting. Okay, so there is a program running here. There is a program written in this server. It is working fine. But when government said no, don't give 5%, make it 6%. What I have to do? I have to tell all the clients, all these 4 clients, that we are no under maintenance. You might have observed some websites will put the tag, the website is under maintenance, it's not available from 3 AM to 5 AM. Why? During that time, what they do, they will open this program, they will go log into the server, open the program, make the change 5 to 6, then they will test it once. They will test it once, whether it is working fine or not. After testing, then they will deploy it. Then deploy, and then they will inform the clients, yes, this is working fine, you please proceed. It takes so much time to just change 5 to 6 also. Making a small change 5 to just 6, it is taking so much time. Why? The whole business is down. Nobody is able to do banking transaction because the server is stopped. The program which was running is stopped. They have stopped it, they are making changes, they have to test it fully. Because if I simply make 5 to 6 and change, deploy, maybe only few customers have to get 6% interest. But it is going for everybody. We do not know. So we have to make the changes. After making changes, we have to test it importantly. So testing will take time. So you have to open this server, open the code, make the change, test it properly, fully you test it, and then you deploy it, and then you start the business. So during that time when I am making the changes, right, the application is down, business is not working, and even to make a small change you have to do lot of work. That is the drawback with this monolithic style. Okay, when I talk about the second style, that is our SOA, right? Again, in the same pizza example, I think you understood the relation here. We have a single unit, right, who is managing everything, and everything is tightly coupled. Scaling is difficult. We have lot of challenges with respect to the hotel also. Now again, this is a programming example, I will come back to that. Then the second concept is service oriented architecture, SOA. What is this style? What does it tell us about, right? Okay, there we have seen some problem. What you were doing? You were writing 20,000 lines of code as a single file, right? Making change in this was difficult. First thing, why it was difficult? I do not know where to make the change. Second thing, even to make a small change, I have to spend so much of time in testing, stopping the program, opening the program, making the change, testing it fully, and deploying. And finding where to make change is a problem. Then even to make a small change, it is taking so much of time. That are the drawbacks here. Next, another drawback is that I am deploying it in a single machine, in a single server. I am putting the whole code. I am talking about monolithic. I am deploying the whole code in a single machine. What is happening? If the server is down, application cannot work, right? There is no backup. If there is huge demand, right? This is a single server. If there is huge demand, this cannot satisfy the request, like our SSC results. Okay, so like this hardware related or also something related to writing the code, we have challenges. We are deploying in a single machine. If this machine is down, it is not working fine. Some network issue came, power failure came, power shutdown happened. We cannot use this application in monolithic. So what they thought, no, Yes, no, there are some drawbacks in monolithic. Let's come up with a new idea. What is the new idea they have come up? They named it as service oriented architecture, SOA. Okay, this has been very popular and successful way of doing business. Same thing I told you under pizza shop. What happened there? They got some specialized teams, meaning when there are employees like this fellow can do, this both can do cooking. If one is not there, other can do that. Business will run. Okay, that is the strategy here. In SOA style, what they proposed, this was proposed in the year somewhere around 2005, 4 to 5, in between that, this was proposed. During this time, internet also started growing. We started getting internet. So whoever was doing business and they wanted to have some software application for that business, everybody followed this SOA. Your SBI online banking, your IRCTC, right, your passport application, right, all your Twitter, Amazon shopping website, Flipkart, like this there are a lot of applications. All these software applications came around 2000. When did Facebook come? Facebook come in, it came in 2007, because they were starting business. When what was available in the market, which technology was there? SOA was the only technology that time. Somebody was starting business, they got internet in their city. He wanted to do some business with that internet. He wanted to build one application. What was the style available? That is SOA. So everybody, when internet was growing, the latest available best style of designing application was SOA. So all these applications what we know were designed using this style only, SOA style. Okay, because that time, during those days, this was the trending technology or architecture, I would say. So all these applications have used this style. That's why this is very popular style. Now what did they propose here? What is the difference between the previous case? What is the difference with monolithic and SOA? In monolithic, we are writing a single program, 20,000 lines. Okay, but in SOA, they told break down that 20,000 lines into 4K lines of programs. Make some 5 small programs like this, and don't deploy them in a single machine. Deploy them in separate machines. Okay, so what is happening now? To make a change, now let me take an ATM example to understand better. ATM or some banking example I will take. This is your monolithic. Okay, this contains the whole 20,000 lines. 20,000 lines. There are functionalities related to withdraw, deposit, pin change, balance inquiry, common functionality what we see in the ATM. So this is monolithic. What SOA states that no, you divide this 20,000 lines into 4,000 lines each or 5,000 lines each. So make one only for withdraw, make one only for deposit. This is for pin change. This is for balance inquiry. Like that, you divide them into some 4K lines. Maybe something is 6K, something is 2K, but you make the changes. This is 5K. You have different services like this. If you observe here, the whole functionality of banking was in a single program in monolithic. Here, all withdraw specific things, we got them into one program. This is program 1. This is second program P2. This is P3, P4. We are writing 4 separate programs instead of one single program in SOA. Okay, so but what is another feature here? In the program 1, that is all about a single business, all withdraw related, withdraw through ATM, withdraw through bank, withdraw using some other with cardless withdrawal, anything, all withdraw related code in a single program. That is your this SOA. All no deposit related, deposit through check, deposit through bank, deposit through ATM machine, all that code is in a single program. So they have grouped together similar functionality into a single file. Now when you have separate programs like this, it is better than monolithic. Why? Okay, government says when somebody is depositing money, instead of 5 you give it to 6. Do I have to stop all the programs? No, only P2 I have to change. Only P2 I have to open the code, I have to make the change, test it and deploy. When I am making change in the deposit part, somebody can withdraw, can work on function properly, pin change can function, balance inquiry can be done. Business is not stopped here. Banking process is happening. Only one module is stopped. That is, your deposit is not working. Whereas withdraw, pin change, balance inquiry, everything is working fine in the ATM. Why this is down? Because we are making change. So it is very easy. Now when I want to make this change of 5 to 6%, earlier I have to search in the whole application. Everywhere every line I have to check, is there any linkage with this, will this impact any other functionality, that I have to keep checking. But in this style, you need not worry about this P1, you need not worry about P3 and P4, only the deposit. Instead of searching and scratching our head with 20,000 lines, it is easy for the small 4,000 lines. It is better than that. And I need not worry about other 3 functionalities. Why? The government told change only with respect to deposit. So only this small program I have to open, make change and do it. Very, very nice. Compared to Monolithic, this is very, very good, because I am here when I was making change, this was 0% available. Availability was 0%, and maintainability is worst, because I have to take lot of time to make change. Here at least out of 4, 3 modules are working fine. So I would say 75% is available, this application. Only 1 module is down, remaining all are working fine. And it takes less time to make the change in this deposit function, I mean to say in P2 function. In P2, to make the change, to deploy it, to test it, it will take very, very less time. It is easy for us, right? That is about SOA style. But if you remember the business of scenario 2, there were specialized people, but we need a central hub, a central manager was required. There should be one manager who should be allocating the jobs. Today you do this, today you do this. There is a need for manager. If there is no manager, they will not work fine. Employees will fight among themselves. No, you know cooking, you do it, I will not work, my job, today I don't want to do cooking, I want to be here only. Like this they will fight. There is a need of manager. Same way, in these 4 services, when I have these 4 programs, there is a need of a central program manager who will be sending the request. When the customer is coming with the request, it will come to here. Accordingly, he will communicate between 4. All 4 have to work together. So in SOA, we have a something called as Enterprise Service Bus, ESB, who is like a central manager. He will be sending all those requests accordingly. Whoever wants that request, he will be satisfying. When you go to ATM, when you select something, there is a need of central page, that landing page is there, where you select an option. Then the request is going to the withdraw part. When you are doing pin change, the request is going to pin change part. So there should be someone who should take all that. That is called Enterprise Service Bus technically, right? This is about SOA style. Now what is the problem with this? This has been very, very successful since 2005. I believe since 2019 or 20, people have been using, and still there are very, very successful projects still running in the world which follow this SOA style. There was nothing who could break this. It was very evergreen, it is still working fine, SOA. But there were some problems which raised slowly. 2005 it was very successful, 2010, 12, 15, it was very, very nice. But slowly, small challenges started coming out in SOA also. Okay, so what are those challenges? Let's see. Now, when I divide this program, I said no, Monolithic you make it to, I'll just clear this all. Right. So I have withdraw, I have deposit, this is 6,000 lines, pin change is some 3,000 lines, balance inquiry is some 2,000 lines. Nicely, it was working fine. Our business was going good. Okay, but what happened slowly? Let's talk about Facebook. 2007, Facebook started. Earlier, during that year, we can only upload a picture. Nothing was there. So the code of Facebook code was somewhere around or the uploading a picture. When I say post, making a post, FB post. This is one program, one service, one program P1. In that whole FB application, this is one program P1, FB post. The number of lines in this FB post was just 3,000 lines. Sorry, it was only 3,000 lines. Why? We can only upload a picture. That's it, our friends can see that. So in FB, one is about posting a picture, another function is about adding friends, another is about changing your profile settings. So like that we have separate programs. People, they have used SOA only. I am talking only about one program here, Facebook post. This is 3000 lines. Slowly in 2008 they bought the like button. Okay, they got the like button. So like button has come. Then in 2009, this in 8, then they got the comment button, comment option in 2009. Then slowly reply to comments. Today we have lot of emojis. If you see, for the picture which I am uploading, I used to have only thumbs up, only this like button. Now I have this emojis, different emojis. I have emojis for comment also. So that 3000 lines of code in 2007, today in 2020 or 2025, if you say, this has become almost around 30,000 lines. Why this? The single program size has increased. Why? Every day they are adding new feature. They added comment part, they added code for reply to comment, they added for emojis, they added emojis for comments. Like this, now we can tag people, we can share the location, tag the location where you are. Slowly they have added so many things in that. So that 3000 lines earlier, I will not say 2025, but they have migrated now. Around 2015 or 16, this became 30,000 lines. A single function, one program P1 in Facebook, which was 3000, became 30,000. Likewise, friends P2, which was 2000 lines, became 20,000 lines now. P3, which was maybe profile setting, which was some 1.5K, it has become some 10,000 lines. Now you see, application was working fine. SOA is very good. You told to divide them into separate parts. We divided them. We wrote code separately. But because of change requirements, because of customer requirements, to give nice business, to do good, better business, they started adding features. Slowly, every day they added features, so that more people use the Facebook. Now you see, only one program P1, which was of 3000 lines, today it became 30,000 lines, which is equal to a monolithic. This itself became a monolithic, right? Because it became 30,000 lines. Why it became monolithic? To make a small change, I have to open that 30,000 lines of code, find out where to make the change, test it, deploy it. SOA told divide them. I divided, but each divided part again, which was a small one, now became very big. Why it became big? Because of change requirements. Day to day we are having. Earlier we did not have Phone Pay, Google Pay, UPI. Now UPI has come. Every website they had to add this UPI feature. Today, maybe in 2026 or 7, we will get QR code based withdrawal. You need not take your ATM card to ATM machine. By only scanning the QR code, you can withdraw money. That is on the way. The feature is coming. Okay, so those kind of new features they are bringing, so that people use more banking. Same way, this FB also, it became every small program P1, P2, P3, everything became monolithic. The code size increased, it got saturated. To make a change, same headache. Search where to make the change, test it, deploy it. It will take so much of time, right? That's why they came up with another architecture. This is very successful today also, but they came up with another style that is, again, this is all about the features, about SOA, what are the benefits of that, we have discussed it. So I will just skip this part. I will come to this microservices architecture. Okay, what is this style? The future is all about microservices. Okay, this is the ultimate style, what a lot of experts and scientists from the world are telling, that we don't have any other style after this. This will be, or this is the only final style they are telling, maybe for next 50-100 years. We do not know. We cannot say any year also, but they are saying this is the ultimate style. What is this style? Okay, we have talked about monolithic, the large code, 20,000 lines. We talked about SOA. I said we had small things, but each of them again 20,000 lines. It became a drawback. All withdraw related here, all deposit related here, we have seen. Microservices, micro means small. It says that you divide this, even this withdraw related thing, you divide this into small services, like this. Okay, you divide the services more small pieces, micro. Okay, right. So when you are dividing here, each service, each program, so I am having P1, P2, P3, like this I have P100 programs, each one small program. Each program should do only one task, that is a strict rule. Microservices follows single responsibility principle. each program in microservices should do only one task, either connecting to database or validating the credentials, username, password, or maybe doing addition of two numbers, or just calculating the interest. So in this withdraw, we have lot of things, no? It's a very 20,000 lines of code. You divide that into very small services. Let each service do one task, only one task. Now what is the benefit with this? Okay, bank says make 5% to 6%. So there is one program P32. Its job is to give interest, calculate interest. It was calculating 5%. So in the whole application of withdraw, even I am supposed to make a change only in P32 program. Just make that 5 to 6, small program, some 20 or 50, 100 lines. Make change, test it, deploy it. See, now when I said that the withdraw is working fine, or maybe deposit, if we talk about deposit here, deposit is working fine. We are making change only in a small program P32. Rest all is working fine. This is 99% available. Out of 100 services it has, only one service is down. Rest all are working fine. And how much time will it take? Will it take us for us to make change? It will take just some 1 minute or 5 minutes. Make a change 5 to 6, test it, deploy it. That's it. It is very, very small independent unit, right? You need not touch the whole withdraw function. People can still do the withdraw. People can still do the deposit. In deposit, only that part of making interest calculation is alone down for 5 minutes only, not 1 day or half day. How much time? 100 lines of program? No, just make a change, test it, deploy. That's it. It will happen very quickly, right? That's why this is one of the successful. Okay, tomorrow government says you add UPI, withdraw using UPI also. I need not change any of the services. I just have to add P101, P102 and P103. I have to add new programs. Existing programs I am not at all touching. In the previous two cases, SOA and microservices, if I want to add a new feature, that application is down. I have to stop the process, add the new code, test it and deploy it. Here, whole application can still be available. It can be working nicely. Why? I need not change those existing 100 programs. I just have to add new programs. Adding program is easy. You are not changing any existing programs. You are just writing new programs and adding it to the chain. We are not touching these things. We are just making change and deploying them. That's it. So it will take very, very, very less time even to make the change and integrate with the existing application. That's why microservices is trending. So in SOA, what the drawbacks were, it was very successful, but day by day, because of change requirements, the service, the number of lines in that program increased to 30,000 in the FB post example, right? Here, if they wanted to add, let's talk about that FB Facebook post here, right? If they want to make change, right? So I said initially in 2007, Facebook post program was 3,000 lines. Okay, when I am using microservices, so I divided them into some 30 services. I want to add a emoji to the picture, I add new feature here. I want to add emoji to the comment, I had to add new programs only. I am not touching those existing programs. Okay, right? So that is the advantage. Everything is working fine. You are just adding new programs. You are not touching that. That's why it is better. That is microservices. Now, there is another important benefit compared to SOA, monolithic and microservices. Monolithic and SOA, both we used to deploy. We used to deploy in physical servers. Physical servers means in our, if you see some companies, there is some servers. If you see some computer science department, they will say that we have a server with us. Server is nothing but a laptop or a desktop machine with good configuration in simple terms. If there is high configuration, it becomes a server. If otherwise, it's a normal client machine, right? So all these, in both these styles, monolithic or SOA style, they used to deploy the application in physical servers. Suppose TCS is running IRCTC project, in Hyderabad location, they will have one server. This server is a system where that IRCTC application code is deployed. Okay, so they used to deploy them in physical servers. right? So when I talk about the ATM example again here, okay, in monolithic style ATM example was in a single server. In SOA style, what they told, deploy them separately, make them we made separate, we made this as withdraw, we made this as deposit, one thing as pin change, this as balance inquiry, and all these 4 deployed in 4 different servers. And there is one central manager in center who is taking care of the talking to these 4. He is taking care of talking to both 4. They are in 4 different physical servers. Maybe this is in Hyderabad, this is in Chennai, Noida, or Delhi. We have these servers there. Okay, what is the problem with these servers? Okay, let's talk about one server in Chennai, for example. Its RAM is around some 128 GB RAM. Okay, that is a configuration, and space is somewhere around 20 TB hard disk. Let's say some simple numbers, right? So this is an application. During some sale, Amazon Big Billion Sale days, or Flipkart, some sales are happening. Normally they get 1 lakh, 10 lakh requests, but on those sales they get 20, 30 or 50 lakh requests. So this hardware capacity of this server has some limitation. It can handle load only up to some 20 lakh. Okay, at a time 20 lakh people go to single SBI ATM and do pin change operation. It can satisfy. But if 50 lakh people are doing the pin change operation at a time, this system cannot handle it. Why it cannot handle? Because this configuration, its hardware is very low. Because of this limitation, this particular functionality cannot function properly. It will misbehave. So is the example of our SSC results. The server where the SSC website is hosted, that is having very less hardware. Okay, so that SSC result, right, in this, maybe it is having some 16 GB RAM or some 10 TB hard disk. It is having very less space. Okay, that's why on the day of result, it is loading continuously. We are not getting results. Somebody is getting quickly, somebody is not getting the result. Why is that problem? The problem is because the hardware capacity is very less. Okay, government thought, no, why should I face this problem? Why don't you increase this SSC result? Board, secondary school board, they thought, no, let's not create problem. Let's give good service to our students. They tried to make this as 128 GB and they made this as 100 TB. Okay, they made this. They purchased. Previously it was just 10 lakh rupees. Now they spent 1 crore and they got this machine. Right? They deployed the results. They announced the results. It is working fine. But 365 days, only one day there is load on this result website. Remaining 364 days, nobody is using this system. Why? They are not publishing any results. Very rare that somebody will go and check the result. Very rare. On the result day, you see, for one student, his brother, sister, neighbor, everybody is looking for result for one candidate. So for 10 lakh students who are writing SSC, almost 10 crore people are searching for them. For each, requests are coming on that particular day. But this is one day. Out of 365 days, one day result, or 1 or 2 days maximum. Remaining 360 days, this 128 GB RAM is unused. This 100 TB is unused. No use. Why they have to spend 1 crore rupees unnecessarily when the business is only for one day? That's why they are not doing it. That's why our SSC result always it is slow. They are not upgrading because that is for one day activity, right? That is the problem with SOA also. In SOA, you were deploying in physical server. On Big Billion Sale days, Amazon website, they used to get huge load. When there is huge load, they cannot, they have to, what they have to do? They have to increase their hardware. They have to increase their RAM and that hard disk space. When they are increasing that hard disk and RAM space, that day okay. Big Billion Sale is happening 1 day or 2 days in a year. Remaining days, that is unused, waste of money. That's why microservices says that you deploy them in the cloud. Okay, because cloud has the feature of auto scalability. Auto scalability means if you deploy a program in cloud, right, the number of requests, it is handling 10 lakh every day. Suddenly someday the number of requests is 100 lakhs. what cloud will do, this small program, no, it will make multiple copies like this. So it will make 4 copies like this. Some request will go to this program, some request will go to this program, they are diverted. Kind of load balancing. We are trying to balance the load. We are sending some load to this program. So this was the program P1. I made this P11, 1.1, P1.2, P1.3, P1.4. Cloud will do auto scalability. Again, cloud, I'm taking a very overview of that, but actually we have something called containers in cloud. So when cloud containers are auto scalable. When there is demand, they will automatically expand the services. So 100 lakh, let it come 100 lakh, let it come 20, 30 or 100 crore. This can automatically scale. When there is no request, it will automatically shrink. It will delete all these services. Only one will be working fine. That's why SOA we were deploying in hardware physical servers. Microservice is special because it is actually dividing into small services. That is one advantage. Second thing, we are deploying them in cloud. So there is no problem about load. Let 1 lakh request coming, okay. 10 lakh, okay. 100 lakh, okay. Right? 10, 20, 100 crore, okay. Let the number of requests come. Your application will be working fine. It will handle as many number of requests as possible because we are using cloud. Right? That is about microservices style. This is also okay. That's why this is the ultimate thing. If you want to get job, if you are in second year or third year, you are studying, you learn only microservices. How to write code, test, deploy microservice application, and you try to make one, build one application using microservices style. I guarantee you will get 100% job placement. This is the ultimate style. If you don't believe, you go to naukri.com, you see some websites, or you ask somebody who is working 10 years in industry or 5 years in industry, experienced guy, you ask, if I learn microservices, will I have good future or not? You will come to know. Right? This is the ultimate style today. Everybody, even your Amazon, right? Amazon, Twitter, Uber, everybody who were using SOA, they have migrated their applications to microservices architecture. Browse in the internet, go through some blogs, you will understand how Amazon, Twitter have shifted their application from SOA to microservices and why they have shifted. That's why the business applications are very working fine and up. Okay, I think I have, yes, see this is one diagram. Amazon website, that shopping website what you are seeing today, right? Everybody has the mobile app and you book, no? This is a Amazon Death Star diagram. They have released in the year 2020. Okay, after migrating the application from SOA to microservices, this was the architecture of that Amazon. There were around 22,000 microservices. 22,000 microservices were there. And every microservice, number of 1.1 second, for every 1.1 second, one microservice was deployed. Meaning they are making change so fast and deploying it. This was officially released by Amazon. Their Amazon shopping website has 22,000 microservices. It was 21,000. Now I know somebody working in this project of Amazon. So he told me that there are 22,000 microservices. And each developer is giving somewhere around 20 to 25 microservices are given to one person to manage them. His job is to take care of those 20-25 microservices. That's it. Okay, so this is about the story of Amazon, how they have shifted it. Like this, there are so many. You see this, I do not know whether it is visible for you or not. This is the architecture of Uber, right? Uber, when they migrated to microservices, this was also released by them in 2021. This is the diagram. You see the small dots here. Everything is a microservice. You see how many microservices are there. They have some around 15 or 18,000 microservices. The Uber app which you are having today, you are booking cabs, no? That is made up of microservices, and this is officially released by them. Right? So this is popular. This is the ultimate style what we have today in the market. So please learn microservices style, understand how to do, write code, test it and deploy. These three things you should know. That's it. This is excellent and working fine. No, these are all again different technologies related to that. Right? So we have seen the different drawbacks. about monolithic and microservices. We understood this is a single program, maintenance is difficult, server is down, the office is down, nobody can work. Here we made it separate. Okay, that we have understood, right? Same thing, the restaurant also we understood how it is changing. Now I would like to talk about the final concept, that is serverless. I am saying microservices is trending today and it is the future. If you learn that, you get job. But there is something serverless. This is just a little added flavor, or I will say a little extension concept of what we have seen in microservices. There is one problem, even in monolithic, in SOA and microservices. Okay, somebody says, okay, today some company comes and recruits you and they take your company. What is the some client gave one request, design a website like passport for me, or design a website like Amazon shopping cart, right? So what the companies are doing, whichever companies they are hiring, what they are doing, they have an office space. In the office space they are having some 100 systems, for example they are having 100 systems, okay, like this in a row, and there are some 100 employees working. Maybe there are some 25 Java developers, for example. Okay, so you are working on this system, let it be laptop or desktop machine, whatever it is, right? What is the process here? In this you have to in this machine here the software is installed, right? The software is installed in this machine, the software is installed. Software I have to install, then I have to write the code, then I have to test it. Assume I am doing microservices only, but in this laptop I should install Java. I have to install Java first, then I have to install some IDE like NetBeans or Eclipse or Visual Code, what we have. I have to install the IDE, then I have to write the code, I have to test the code, then I have to deploy it in cloud. Okay, these 4 things, installing Java, installing the IDE, some developer tool, then writing the code and testing, I have to do in that machine only. Okay, suppose that machine is down. What will happen? You have to take another machine, again install Java, again install IDE, again writing code may not be required because code you are taking backup in the cloud. So that is not required, but installing the software and installing the IDE is always common. Take this machine, do this. Okay, suppose today you were in India, you were doing this. Suddenly you have to go to US for some work. There you went. After going there, your boss calls and says, please urgently make a change in the program. There is a bug in your program. You have to make a change in the program. Then in US, what you will do? Again, you will take somebody's laptop or system. Again, you will install that software. There is no guarantee that the software is installed. You will install the software, you will download your code, you will execute it here, make the change and deploy it. This is what you are doing here. So wherever you go, there is a headache of this installation of software, installation of the IDE, right? That is one problem. Another problem about machine learning, I will talk little about that, right? You are doing some project and you downloaded the code from some Kaggle or GitHub. So 2.7.2 Python version. You were looking for some clustering algorithm in machine learning, one algorithm in machine learning. That code was written in this version of Python. Today the version is 3.0.2, for example. It's not 0, but this is the version of Python. In your laptop, in your machine which you are using, 3.1.2 is installed. Okay, but the code which you downloaded was written in this version. When you download this code from Kaggle or some GitHub and you try to execute here, it will not work. It will say there is some package issue, compatibility issue is there, right? That kind of problem we will get in this system, because you have installed a latest version. That program belongs to it. Again, there is a problem. What is the solution for this? What you can do? Either you have to install 2.7.2 in your laptop again and then run this code, or you don't uninstall, you let it be 3.1.2. Make changes to your code, make changes to your existing code. Whatever you got from the internet, Kaggle or GitHub, you open that code, make changes accordingly, then run it. So again, it's a headache, right? So we have problems related to installing the software, we have problems related to version of the software also. And And if you are not available here, if you are traveling somewhere, again you have to take a machine, again install. These are the problems. Serverless architecture or serverless computing says that you need not maintain the servers. As a developer, you need not maintain the server. Means you need not install anything, you need not worry about the version, don't worry anything. Here you should have one electronic device with good internet connectivity. You can work anywhere in the world, wherever you are. This laptop is gone, no problem, take another laptop, work there, right? You are in India today, you are in US tomorrow, again you take anybody's laptop, you can work. You need not do the installation of hardware or any software installation, anything. Everything can be taken care by the cloud provider, serverless provider. So what we are doing, let me tell you what is serverless. Again, there are some common providers of serverless. Again, we do not manage servers, right? We do not take care of the headache of managing the servers. So here, yes, we have three very popular serverless providers: AWS, Azure, and Google Cloud. What is this? I'll talk about AWS. In AWS website, you log into that website. Okay, in the AWS website, you can write code, you can test it, you can deploy it. You need not install. You want which language you want? You want Java? You can do that. You need not install. You want Python? You can write that code. You want to do C#, .NET? You can do that. You want to go with Ruby programming language? You can go with that. Whatever programming language you want. You select the programming language, you write the code, you test it, you deploy it in the AWS website. Website means it's cloud. You are having some credentials. You log into that, you write the code, you test it and deploy it. Okay, today you are in some other place, again take any device, log into that website, make changes. Everything in cloud. Your code is in the cloud, your database in the cloud, everything is there. Testing, writing, deploying, everything in the cloud. You need not install the software also. You just have to log in to that web page, login credentials, select your program, continue programming. Yesterday you were writing some program, it is saved. You open that, you continue programming. Your version problem is there, you want version 2.3.2, you will get that. You want 3.1.2, you will get that. Just change the version. You need not do any installations. You need not worry about the hardware. That's why you need not manage server. Serverless means, otherwise what was the problem earlier in when I was talking about microservices, in that company I should have a machine, I should install softwares in that and all headache is not there for us. Everything is taken care by the cloud provider. So in market we have three major providers: AWS, Azure, and Google Cloud. Okay, in those things you just have to log in, select the programming language of your choice, write the code, test it and deploy it. You want to build web applications, you can do everything in that. You need not install any tools or IDEs in your laptop. Okay, even in mobile, from mobile also you can log into AWS. Your boss calls and says, yesterday you wrote a program, it was 5% interest, today you make it 6%. Just from mobile, log into AWS, open that program, you can edit that, save it, test it, deploy it. From mobile also you can do that. Okay. So this is about serverless computing. Everything is there, everything in cloud. Your laptop does not need, laptop is gone, no problem, my code is safe. I need not worry about installation. Within seconds, you take another system, log in with your credentials, write the code, test it, deploy it there. Everything is serverless. You are doing everything in the cloud itself, right? These three are very, very important. Among that, AWS is very trending. Azure also has the good market. So AWS is one thing. So I would say you learn. So again, in AWS actually, or in serverless actually, we are writing microservices. Okay, we are writing programs. No, those programs are microservices. We call them here as functions. So serverless is all about, you have a website. You need to have one electronic device. Log into that, open your website, write code, test, deploy, everything in the cloud. Today you are here, you are in another country, you are in some other place, wherever you are, you can manage that. You can write code, test anywhere in the world, wherever you are. System is crashed, no problem, another system you take, right? You need not worry about anything. In software installation, you need not do. Everything they will do. What about the load? Anyhow, microservices we are deploying in cloud. No, I told you when I discussed microservices, we said that we are deploying them in cloud, right? So we were deploying this in cloud. Why? They are auto scalable. if the load is very high, load is very low, everything will be taken care by the cloud. So when I am writing, testing, deploying in the cloud, what is the best thing what we have in the world today? Everything in cloud I am doing it, right? That is serverless architecture. So serverless is trending today. People are trying to build their applications, write code, store their data, everything in serverless computing or architectures. So I was talking about these three: AWS, Azure, Google Cloud. If you learn, you see there are every day there are some 1,000+ jobs opening on this. I'm talking a very small number, maybe 10,000 also, right? Every day there are openings. People are looking for AWS developers, for Azure developers, meaning you should know. See, you know C++, you know Python programming, very good. You are writing in your laptop. Instead of that, you write in the cloud. You open AWS account, you write code there, you test it and deploy it there. So you should know how to use the environment. Learning AWS, I will say it will take almost just 30 days time. You can learn this skill. Okay, so serverless computing, if you learn, if you know what is microservices and plus any one of these AWS or Azure, if you know, for example, if I talk about AWS, this is the most on-demand job what we are having today in the market. Though there are so many jobs, there are jobs for database developer, there are jobs for Java developer, full stack developer, even Java developer, full stack developer, everybody will move towards microservices in future. Any application you build, you have to talk about microservices only. I do not know whether you are aware or not. If you have studied about web technologies, right? Web technologies, or somebody is calling today full stack web developer. Okay, all those technologies what you were using were single page applications. They were all SPA, single page applications. Here, let me talk about that. SPA, single page applications. That full stack, no. This, you might have built some applications, right? Web applications. If you are looking for a software job, you might have learned some HTML, CSS, JavaScript, no, all those stuff, right? Today, inspired from microservices, they are not building, they are not following this style. There is something trending in market, that is micro front end. Inspired from microservices, somebody has proposed a new style of designing web applications. This is trending. Tomorrow this will occupy the market. Learn this micro front end. Don't learn the traditional way. That is required. At the basic level, you should know what is HTML, CSS, how to write application. But today micro front end is trending. Micro front end is used to design web applications. Okay, this is the latest style. So ultimately, I would say that serverless computing, anyone, either AWS or Azure plus microservices, if you are learning, if you are looking for a software job, you will have huge demand. Okay, and the conclusion of my session, I would like to talk about this Gartner's hype cycle. Okay, I love this Gartner. Every year in the month of October, every year they give 10 top skills. Okay, maybe 2024 October they released some 10 skills which will be ruling 2025 or maybe 5 years from there. Okay, so Gartner is one scientist, it's an organization now. Every year they do prediction. They will predict next 5-10 years which skill or which technology is going to have more demand in the industry. Okay, so they have, this scientist Gartner have proposed one hype cycle. What is this hype cycle? See here, anything which comes in the market, even if you take artificial intelligence, machine learning, everybody, when it was started, everybody was talking about it. Even today people are talking about machine learning, AI, everywhere you go, any lecture you attend, any meeting you see, everywhere people are discussing about AI. Why? There is a full hype about that. Gartner says anything which comes into market will definitely have hype. Anything which comes into the market new will definitely have full hype, but after a certain stage it will definitely fall down, and then slowly it will be narrowed down to some specific requirement. People, if you see, maybe some faculty are also there, everybody, irrespective of the domain, mechanical, EEE, electronics, everybody have used AI techniques to solve lakhs of problems. Any problem they are finding, weather problem, any climate problem, underground problem, apply AI. For everything we have been applying AI to do to solve the problem. But after lot of research, after lot of things, Now people will come to a realization that AI can be used only for some image processing, or some image specific related things, or some video processing only. It cannot be applied for every domain. So I am saying an example. Gartner clearly states anything which comes into the market, any new technology comes. SOA came, it was very nice, slowly it fall down. Microservices came, it is very nice, we do not know what is its used for. People are telling it will come, but Gartner says no, I don't believe in that. Anything which comes into the market, see, technology trigger, a new technology will come in the market. Python came, everybody started Python. Machine learning came, everybody ML, deep learning, everybody is running behind that. Right? Then there is a peak of inflated expectations, full peak demand, right? Then thought of disillusionment, they will come to a realization, no, this is not working, this is not working, this is not working. You see, today when you attend some industry talks, people are telling there is a big fighting happening, should we use AI or not? So they are coming with a new, again, something new, ethical and responsible AI is coming to market. People are bringing new rules. Even UK government has passed this bill in 2024. Anybody who uses UI, they have to take approval, and they have given strong guidelines. Means they have already realized AI is not our cup of tea. We can use it, we can take advantage, but let it not go beyond some extent. So they have, the UK Parliament has passed a bill. So they will realize that. Then slope of enlightenment. After so much of research, they will come to a point. Yes, this can be used only for this purpose. Right? From there it goes straight. It is used for that purpose. So whatever technology comes, it definitely have to follow this Gartner's hype cycle. Today machine learning, I am talking about serverless, tomorrow something else might come. We do not know. Some people can invent something else. Serverless is there, something else might come. Microservices might get into nano services. When I gave this talk, one scientist told me, you have shown this diagram, so do you predict nano services tomorrow? He told, because SOA, then micro I told, he was talking about nano. Will you tomorrow come and say, no, I have come up with a new idea of nano services? We do not know. We cannot comment on that. So Gartner says that. So this is one of my favorite slides. Anything which comes in the market will have hype. Later it will fall down. People will realize what is good or what is bad, and then they will go. For now, there is full hype and full demand for serverless and microservices, and it is expected that it will not follow this hype cycle. It will follow some other hike cycle. Right? So with this I conclude my session. I hope you understood at least the basics of how software applications are built and what is trending today in the market. I am open for queries. Anything you want to discuss, please let me know.
Thank you, sir. Students, if you want to ask any questions, audience,